Okay, we're now going to look at partial fractions when one of your factors in the denominator is squared. So the natural instinct is to write your partial fractions as a lots of x plus 1 plus b lots of x minus 2 squared, putting in both the factors that you've got on the denominator. However, it is possible that I've also added in some factors of x minus 2. Okay, because my common denominator here would still need two factors of x minus 2 and an x plus 1. However, not all of my fractions will be over x minus 2 squared. One of my fractions may just have a single factor of x minus 2. So we need to consider that. Sometimes when you do this, it's 0, but in an exam, even if it is 0, you need to show that it is 0. So we always assume it's there, even if it means showing that one of those factors is 0. Okay, so let's have a look at this then. Same process as before, we multiply through by the denominator. Remembering this has only got one factor of x minus 2 on the denominator, so it will have a factor of x minus 2 still there, because I've multiplied through by x minus 2 squared. Same as before, choose a nice value of x. 2 is a nice one to start off with, so on the left hand side I get 12 minus 3 is 9, 0, 0, I have 3 lots of b. Okay, so just checking that through, that looks good. B is 3. Like we said before, if you get nice values, you kind of know you've probably got it right. Horrible fractions, just double check. It might be correct, but it's worth double checking. Okay, so we've got that. Now we'll look at let x equal minus 1. So if we let x equal minus 1, we're going to get a 0 there, a 0 there, and we're going to get a, so minus 1 minus 2 is minus 3 squared, I get 9 lots of a, and on the left hand side I get minus 6, minus 3, minus 9, a is minus 1. Again, nice value, I can probably trust it. Now I've got a slight issue, because if I try to let x equal, I need to find my c, if I try to let x equal minus 1 to get rid of my b, I get rid of my c's. If I let x equal 2, again, I'll eliminate my c. So I can't do it as easily as I did before, but luckily I now know what a and b are. So I've got two options. I can just let x equal something nice. 0 is usually a good bet. If I let x equal 0, then I'm going to get minus 3 on the left-hand side. X is 0, so I'm just going to get 4 squared times a, but I know a is minus 1. Minus 4 from there. Here, I'm just going to get one lot of b, but I know that b is 3. So I can put that in, and then x is 0, I'm going to get 1 times minus 2, lots of c. And now I can just figure out what that c is. So minus 6, minus 2, c is equal to 1. So again, it doesn't have to be a number that eliminates all the rest. Once you know the others, you can just let x equal 0, for example. Or if you've already used 0, maybe I could let x equal positive 1, or minus 1, or something I haven't already used. 0 is usually the simplest though. There is an alternative technique. I can equate coefficients. Like we said, this here is always equal to the right-hand side. So I must have the same number of x squareds on both sides. I have 0 x squareds here. I'm just going to say what I'm doing. Equate coef of x squared. I know that I have 0 x squareds on the left-hand side. On the right-hand side, there are only two terms which give me x squared. This is why I chose x squared rather than x. I get a lots of x squared from here, so minus 1 of them. And from here, I get c lots of x squared. So minus 1 plus c must equal 0. C is 1. It doesn't matter which technique you use, you'll get the same answer. It's entirely up to you and your personal preference for which one of those two techniques you're going to use. The main thing to remember though, if one of your factors on the denominator is repeated, you must have it there, one of the fractions with just one x minus 2 and one with two factors of x minus 2. We don't bother with having two factors like that because that wouldn't mean our common denominator needs to be an x minus 2 squared. We would just have a common denominator in this case of x minus 2, x plus 1. That would not change anything. We need this quadratic denominator. And we're done.